Hi, I'm going to showcase our graph algorithm agents for our native application. This makes it really easy for people familiar with graph algorithms like PageRank, Betweenus, Centrality, Leiden, etc., to get up and running and run jobs on their data without having to learn the syntax. But equally, for people who want to provide natural language question capability to their business users without them having to understand algorithms, knowing which one to run, this experience makes it so easy to get those answers. So, right now, I'm in Snowflake's intelligence product. And I'm going to start off with asking my first question. Now, one of the things you do have to do at the moment is you have to prepare the views of the airport and the routes being the relationships. So that data has to be pre-prepared. So that's something like the data engineers could do if you are providing this to your business users, or if you're a data scientist and you want to start running and scheduling jobs, you would have to prepare this data. So basically, we're saying I want to identify the weakly connected components within these airports. So at the moment, I'm a data scientist, right? I know which algorithm I want to use. And one of the great things about Snowflake Intelligence, whether you're using this or whether you're going in through Cortex Analyst, it explains what it's doing at each step. So right now, it's figuring out the configuration it needs to run, where it needs to write the results, and then when it's computed that, it will also update the semantic view. So here that we can see it's identified over 400 weakly connected components. So a weakly connected component is a set of airports that are all connected to another set of airports via a flight, and then it's identified the distribution. Now, that's all good. Now, supposing I then want to identify what is the most, no, tell you what, give me the top 10 most important airports. Right, this time I haven't told it the algorithm I want to run. I just asked it like something that a business user might ask. Right, they're going to say, "I want to know the most important airports." They haven't said what particular algorithm they want to use. And here, the GDS agent is able to say, "Hey, I think you really need PageRank, and I'm going to run PageRank algorithm over the data that is available to me." And then come back with the list of scores. Again, you'll notice it's updating the semantic view. That's really helpful for it to be able to combine and use other queries. So later on in the example, we'll see it running SQL, and it can do combine the SQL tables together, the results tables, so you're getting more helpful information. Now it's executing the SQL. And it's even telling me it can't include the airport names because that information isn't available to it yet. So that's something that would look to improve in future iterations. There we go. So we have the most important by rank. Now, supposing I would like to know what algorithms, no, not what, I want to explain algorithms available. So here, right, this helps me actually learn and explore the product. So imagine I'm a data scientist. I've just installed this thing. I don't want to go off and read the documentation. I can just ask it, and it says, right, I've got centrality ones and importance, page rank, for example. Yep, I'm completely satisfied with this. Community detection, I've got Louvain, Leiden. um, pathfinding algorithms, node embedding, and similarity, for example, right? And it gives me some example detector. One of the other great things is its ability to make use of the semantic view. So let's say that I want to use run fast RP. So fast RP is a node embedding. So basically, it just calculates some numerical scores for each node, essentially embedding information. Right. So here, I want to use an embedding algorithm, FastRP, so you can see the configuration that it's produced. So if I wanted to go and automate this and run a scheduled job, I could copy and paste that configuration, and then I've got something that I can run repeatably. I've got my results, and now I want to find out find the top 5 as similar airports. So let's use car similarity, airport pairs, airport 12 and 15, perfect match, 11 and 12, 11 and 15, 15 and 11. These likely serve similar functions in the network. They could be regional hubs, alternative airports, or complementary airports. Um, Obviously, we need the names for this to be a bit more meaningful, but I think you can see the benefit of here.